This is a lesson on the idea behind position, velocity, and acceleration. I'm going to combine two different things. I'm going to combine the step diagram and the chart within the context of this problem, or this type of problem. So the first thing is, let's talk about the step diagram. So just like we had in Unit 4, we're going to call position down here. Usually that's some kind of, actually, oftentimes it's x of t. T is the independent variable because it's time. It's measured in things like miles. Maybe it could be measured in centimeters. It could be measured in inches. But it's some kind of a distance kind of time, right? So that's some kind of distance. When you go up one step, it's called the velocity. And that's x prime of t, or v of t for velocity, and that might be in miles per hour. So some kind of time measurement there. The last step is acceleration. And that's going to be x double prime of t, or v prime of t, or a of t. And that's going to be in miles per hour squared, or miles per hour per hour. Remember, going up these steps, we're going to differentiate. So that's how it looks in the step diagram as you're going up, where you go to position, velocity, acceleration, and we're differentiating as we go up there. And so just keep that in mind. So then we can also kind of convert that to the chart. And we can convert that to the chart in a really similar way. When you think about the chart, I'll do my best to draw this chart in here. So if this is position, x of t, this is velocity, v of t, this is acceleration, and that would be a of t, is usually the way it would be, but it's still differentiating as you go. So think about it, as you go this way, you're differentiating. Okay, so just differentiation. It's just like going up the steps. Now, the position can be either increasing or decreasing. That would mean that the velocity is going to either be positive or negative. And we still aren't going to get anything with those. Now, if the velocity is increasing, then acceleration is really going to be positive. If velocity is decreasing, acceleration is going to be negative. Now, there's a little bit of a caveat on there, because velocity, I like to refer to velocity as speed with direction. Okay, velocity is speed with direction, meaning if velocity is positive, the position is moving left. So we can put in here let me put in here, moving, to the right. If velocity is negative, the thing is moving to the left. It could be up or down, so if velocity is positive, the particle might be moving up rather than left, or rather than right. If velocity is negative, the particle might be moving down rather than to the left. But that's the idea behind it. So speed is velocity with direction, meaning if velocity is positive, then the object is going to the right. If velocity is negative, then the object is going to the left. Now, we can talk about speed also, whether speed is increasing or speed is decreasing. But we have to think about those in terms of this. If you think about speed, speed is increasing if velocity and acceleration have the same sign. So if they're working together, so velocity and acceleration need to be working together. So speed is increasing if velocity and acceleration have the same sign. They have to be working together, meaning if velocity is positive and acceleration is positive, then the speed is increasing. But speed is decreasing, and remember, we're talking about speed now. Speed is decreasing if velocity and acceleration have opposite signs. Okay, so velocity and acceleration need to be working against each other. In order for speed to be decreasing, so speed is decreasing if velocity and acceleration have opposite signs. So if velocity is positive but acceleration is negative, then we're working with opposite signs. So speed is actually decreasing in that case. So the other thing that you can think about speed is really the absolute value of velocity. So speed is the absolute value of velocity. So think of that. I'll write it down here. Speed is the absolute value of velocity. So it's velocity without a sign. So when you have a problem like this one over here, if I had to do this example right here, make this example 1. Some things you're going to have to do from your homework. And it says a particle moves along the x-axis and the position is given by this. Determine the speed of the particle at t equals 2. So if we wanted to know the speed at t equals 2, what we'd want to do is we'd want to find the velocity at t equals 2 and just do the absolute value, or take out the sign. So what we'd want to do is we'd want to say, okay, well, if x of t is equal to t squared minus 10t plus 34, then v of t is just the derivative of that, 2t minus 10. So if we plug in 2, v of 2 would be 2 times 2 minus 10, which in this case would be negative 6. So the velocity is negative 6. And whatever unit of measure that they don't use a unit on this one, but the velocity is negative 6, which means the particle is moving left at a speed of 6. So the negative really refers to whether it's moving to the right or to the left. In this case, it's moving to the left at a speed of 6. So if we just determine that the speed is 6 and submit that answer, we should get the right answer, because you really want the absolute value is what you want to do for speed. Let me show you a new problem. Now, determining whether a particle is speeding up or slowing down. So remember, if speed is increasing, if velocity and acceleration have the same sign. Speed is decreasing if velocity and acceleration are working against each other. So in order to figure out if a particle is speeding up or slowing down, we got to check both signs. We got to check the velocity at 8 and the acceleration at 8. So let's look at that one. So for example, if v of t is equal to negative 2t plus 12, if we check v of 8, v of 8 is negative 2 times 8 plus 12, which is negative 16 plus 12, which is negative 4. All that tells us is the particle is moving to the left at 4 units per whatever time it is. It doesn't tell us if the thing is getting faster, going to the left at a higher rate, or if the particle is going to the left at a slower rate. What we have to do is we have to take the derivative of it, which in this case would be negative 2. And what that would indicate is so v prime of 8, which would be a of 8, in this case it's a constant, so it's negative 2, since velocity at 8 is negative, and acceleration at 8 is negative, the particle is speeding up in the left direction at t equals 8. So that's the work that you would have to do for this problem. So since velocity in this case at 8 is negative 4, and speed or acceleration at this case is negative 2, the particle is actually speeding up because the velocity and accelerations have the same sign. And if we get that, that's what we would do to calculate that. So you have to look at both velocity and acceleration. So this one is asking the particle is at time t equals 0, the velocity is given by this. Determine if the particle is moving to the right or to the left at 5. Remember, it's moving to the right if velocity is positive. It's moving to the left if velocity is negative. So all we have to do on this one is just check if v of t is equal to 2t minus 3. Let's check v of 5. V of 5 is 2 times 5 minus 3, which is equal to 7. So since v of 5 is positive, according to the chart, the particle is moving to the right. If you look back at that chart you wrote at the beginning, the particle would be moving to the right. So since that's 7, it's greater than 0, the particle is moving to the right. Okay, so hopefully I think that will cover all of the problems that you need to do. I'm just going to flip through a couple more just to make sure. Here's one that is a little different. This one is asking for the acceleration. So I'll call this example 4 in this grouping that you might have. It says x of t is equal to negative t cubed plus 15t squared plus 33t. And it's asking for the acceleration at 3. So we need to take the derivative. X prime of t is negative 3t squared plus 30t plus 33, and x double prime of t, which is the acceleration, in that case will be negative 6t plus 30. So now if we try to figure out what a of 3 is, we would do negative 6 times 3 plus 30. In this case, that's negative 18 plus 30, which is 12. That's our answer. So if we just type in 12, as long as I did my calculations right, I should get that right answer. Okay, I think that's all the types of things. One last thing. Velocity, or the particle is at rest. The particle is at rest when a particle is at rest when the velocity is equal to 0. So if we wanted to know when this particle is at rest, we would just need to figure out when does this particle velocity equal 0. So you'd factor this and then solve it. So on this one, if I did this example also, we'd say, okay, well, we need to know when 3t squared minus 24t minus 27 is equal to 0. If I factor out a 3, I would get this. Okay, notice it asked me for the times t greater than 0. So if I factor this, this would factor into t minus 9 and t plus 1. So that means t equals 9 or t equals negative 1. Since they wanted t to be greater than 0, this is not the answer, so we're just going to use 9. And that's it. Okay? Hopefully that's the end of them. Okay, I think that's all the types of problems you're going to see in that grouping. Determine all the intervals when the acceleration of the particle is positive. So remember, acceleration being positive, all we have to do is take the derivative of the velocity. So if you go way back to the beginning, if we wanted to know when the particle, the acceleration is positive, we just have to differentiate velocity because we got to get to that top step up there, okay? In here, maybe I should put that this is an equals here, this is an equals, and this is an equals, so it doesn't look like a subtraction, okay? So you just know that those are equals signs there. Just so you know, we're talking about equals in there, okay? So I don't want you to think that those were subtractions. So let me go down to the bottom. So let's look at this problem here. Scroll down. I get to the bottom here, example 4, example 5. So this would be example 6. So if we want to know when acceleration is positive, we know that the velocity is equal to 5t to the 4th minus 20t cubed. So acceleration is equal to 20t to the 3rd minus 60t squared. So what we want to do is we got to get our test intervals, similar to what we did when we were testing for increasing or decreasing. We got to test for whether this thing is positive or negative. So we need to figure out when 20t cubed minus 60t squared is equal to 0. We got to get our test intervals here. Well, we're going to have to factor this. So if we factor out 20t squared, we will have t minus 3 here. So that means the acceleration is going to be 0 when t equals 0 or 3. Those are our test intervals that we got to work with. So here's the same way we did it before. If t equals 0 or 3 here, we have to test a value in between there, and we have to test it on acceleration. So what should we test? We should test -1 here, I would test 1 here, and I would test 4 here. And I test it on acceleration. Now I can test it on this acceleration model. That's an acceleration model. I could also test it on this acceleration model. It really doesn't matter which one. Sometimes I go to the factored one because I feel like I can get negatives in there. Notice that if I put in -1 into this one right here, put in -1 into this, I would have 20 times -1 squared. So I'd have 20 times -1 squared times -1 minus 3. And I'll only do that for the first one because then you may hopefully be able to see how I got that. And if you look at that, I have a negative quantity because I have 20 times +1 times -4, so that's a negative quantity. If I plug it into 1, notice I have 20 times 1 times -2, so that's still negative. And notice when I plug in 4, I have a positive over here. So what does that mean? That the interval on which acceleration of the particle is positive is going to be from 3 to infinity, and don't include 3. You'll be much better off. So we're going to do from 3 to infinity, and that should be our correct answer. And you can see the same kind of chart that they did on that. So if we're same kind of thing, if we're determining when the intervals of particle is moving to the left, we would just try to figure out when. If the particle is moving left, then velocity is negative. So we got to take this, if this is the position, we have to take the derivative. So that's 3t squared minus 18t minus 48, and we have to solve this one. So we got to set this equal to 0. 3t squared minus 18t minus 48 equals 0. And we have to do the same thing we did on the past because we got to figure out when velocity is negative. So if we factor out 3, we'd have t squared minus 6t minus, and if you think about 40, oh, sorry, I shouldn't put that parenthesis in there. And if we do, if you think of 48 divided by 3, 16, sorry, 16 equals 0. If we factor that, notice particle moves to the left, t is greater than 0. So, so we just have to figure out when t is greater than 0. We're going to get some false information on this. Notice that we get t minus 8 times t plus 2 is equal to 0. So t is equal to 8 or negative 2. We don't have to account for negative 2, right? So we only have to account for in between 0 and 8 and greater than 8. We don't have to account for 0, but we get to include 0. Okay, we get to include 0 because over here at negative 2, we don't have to worry about that one because notice up here it says t is greater than 0. So now we just have to check the sign of velocity. So we'll check 1 here, we'll check 9 here, and we're going to check it on this. I think the easiest thing is to check the velocity on that highlighted thing. So if we plug in 1, notice that that quantity would be negative, that quantity would be positive, so we know we get a negative. If we plug in 9, that's positive and that's positive, so we get positive. So in this case, we're not going to include 8, but we are going to include 0. So our answer on this, because we want it moving to the left, so v of t is negative between 0 and 8, not including 8. So the particle is moving to the left between 0 and 8. Oops, sorry, that should be an open parenthesis. So I ought to be able to do this, and I'll be able to do 0 and 8, and that should give me the right answer because it's not, you remember, going to the other side of 0 is not in our domain. Let me make sure it's the same kind of problem. Just let me make, I'm just going to make sure. So velocity and acceleration, we need to figure out when they're the same sign. So remember, go back and we got to kind of figure out what's the acceleration and the velocity and make sure that they have the same sign. So you're going to have to do both of that work. I'll maybe come back to a problem like that, but let me go to this kind of problem. So let's look at this kind of problem. Again, you got to make sure you know what you're looking at. This is the position graph. Okay, so we're looking at the position graph. Particle moves along the x-axis, so the position is given by x of t. This graph is shown here. The inflection points of the graph are marked in green circles. Find all the intervals in which the speed of the particle is increasing. So remember, in order for speed to be increasing, when velocity and acceleration have the same sign. So let's look at this one. So let's take a look at this graph. Notice that if you go back to the chart, if we go back to the chart and we look at when velocity and acceleration have the same sign. So notice, remember when we go to that chart or that steps, hold on a second, let me erase that. When we go to the steps and we differentiate. So this is x prime, this is x double prime. So you got to think about when we have the same sign. So think back, I'm going to scroll all the way back up here and I want to look at this chart. When we think about this is going to be concave up, concave down, just like on the other one. Now, in order for speed to be increasing on this, in order for us to look at this graph and determine if speed is increasing, in order for speed to be increasing, notice that in order for the speed to be increasing, acceleration and velocity need to be the same. So that would be here and here. Speed would be increasing. Notice that those would have to be the same. So when we think about what's happening here, in order for speed to be increasing, we would need that to be true, or we would need those to be true. So we need a graph that is increasing concave down, or concave up, or we need a graph to be decreasing concave down in order for our speed to be increasing. So think about that thing. I'm going to scroll way down and I'm going to kind of unpack exactly what we need. If we are looking at a position graph, so since we're looking on this problem, since we're looking at a position graph, in order for speed to be increasing, we need v of t and a of t to have the same sign. So if we need v of t and a of t to have the same sign, we're looking at a position graph. We need a graph to be concave, up, and increasing, or concave down and decreasing. We need those to be working together. So if we think about it, concave down and decreasing, it looks like that's happening from 5 to 8. So from 5 to 8, that's one place. Concave down and decreasing in this problem from 5 to 8. Concave up and increasing, looks like that happens from 10 to 12. So if I needed a new one, I could put a comma or I could do that, and I'm going to do 10 to 12. Then we also get concave down and decreasing from 13 to, it looks like 18. So 13 to 18. That's another time concave down and decreasing. So if I do comma, I guess I'm going to have to do a new one here. Hit that plus sign to get a new grouping. And if we do from 13 to 18. That should be our answers. And then you'll get through the explanation. But we're kind of looking at places where they both have the same sign. Okay? Let me see one more problem. Hopefully we can. So same kind of thing here. Speed of the particle is decreasing, but notice we're looking at velocity here. Okay, this is the graph of velocity. So if we are looking at velocity on this, I don't know what example this is, I'm going to call it example 8. Looking at v of t, we need it to be positive and increasing, or negative and positive and decreasing in this case. I'll unpack that in a second. Or negative and increasing, because it's asking when our speed is decreasing. So we need these two things to be acting against each other. Okay, so we need those two things to be working against each other when you think about acceleration. Acceleration being this, because we need v of t to be positive and a of t to be negative. Well, when a of t is negative, according to our chart, v of t is decreasing. Okay, so that's how I got positive and decreasing. Or we need v of t to be negative and a of t to be positive, because we need them working against each other. When a of t is positive, v of t is increasing according to our chart. And we're just looking at, again, we're just looking at v of t. So we need v of t to be positive. That's above the x-axis. So remember that idea there is above the x-axis. This is below the x-axis. So here's the two situations we went. We went above the x-axis and decreasing, or below the x-axis and increasing. So above the x-axis and decreasing, that looks like that's happening from 5 to 7, right? So from 5 to 7, hopefully they don't include I'm a little concerned about how they're going to deal with that, but I'm going to do my best and just estimate that they don't care about that, but they may balk it at this 14 right here. So I may need to split that interval, just so you know, but I'm going to try this first, and 9 to 17. The other one that I would say on this is, notice that down here, negative and increasing from, oops, that, from 0 to 1. So here, 5 to 7, velocity is positive but decreasing. 9 to 17, velocity is still positive but decreasing. Here, and I may need to split this interval, so they may balk at 14, so I may need to split this 9 to 14 and 14 to 17. I don't know how they're going to read it, but I would be okay with what I wrote here. And then notice velocity is negative but increasing right there. Let's try that and see if they give it to me. Yeah, they're okay with that splitting. So that's my places where the speed of the particle is decreasing because I'm looking again at the velocity. So you may need to try a bunch of these problems to kind of get your idea, but think back to the chart and the steps. I think that that's all I'm going to do right now because this video is really long at this point.